Back at the time was not that easy to install, things didn't work, you fumbled around the hardware, etc. But eventually I used all versions from then on, 2.0, 2.1, Warp, Warp 4, so an Ecom station in various versions, 1.2, 2.0. So now for what I did in software, at some point in time I just was getting into the details of programming. I'm also a software engineer and I've been doing embedded software development for a long time. So I got interested in device driver programming because that's something that is not that well documented. It's always a challenge to find out how things work. So it can be fun, it can also be frustrating. But what I did in the past, or let's say the past couple of years, that made it somewhere to some official thing or not, is at some point in time Jan van Wijk had some problems with a full screen display regarding the mouse cursor, just wouldn't work. So there was a bug or a shortcoming in mouse.sys. First thing I gave him a workaround that he could put into the DR Windows library that he's using for the GUI, and eventually I fixed it in the mouse driver itself. And first of all, I put a version onto hops, a fixed version of mouse.sys. But I also contacted the AMouse developers so that the fix also made it into the mouse driver, into the AMouse mouse driver. So it's in there, and it's in there for quite some time now. So that's the problem is history, so to say. Then, at one point in time, I needed this virtual floppy disk driver to, as many of us, to extract these image files from IBM, where, for example, when you install a service pack, you always have these image files, and they're basically kind of floppy images. And if you want to get to the content, you have to have a virtual floppy. You basically either you have to have the floppy disk, or you need something to that emulates a floppy. And there was this driver around called bfdisk.sys. It has a long history. It was developed by, I think initially it was developed by some IBM employee or something. But it has some deficiencies which Daniela Engert fixed at some point in time because this driver was using some dynamic memory allocation function inside the kernel that was basically destined to be used under OS 2.1.3. In other words, when the 286 was out. So all these old functions are still in the OS 2 kernel, and you shouldn't use them. But so she fixed it and used the newer memory allocation functions that were basically designed to be used by the 32-bit OS 2 version. Unfortunately, there was still some problem that you could still get some, if you use the early meminit command equals true in your configs, you could still run into a problem that would tell you that you didn't have enough memory, where obviously you did have enough memory. So I fixed this last problem, and I did some, let's say, cosmetic updates to show up in resource manager, blah blah blah, things that were I just hacked in, so to say, and this was put out on the internet, and it's also on MATLabs. Then, in the past, it's quite a few years ago, I helped fix, I did some work on, some fixes on X Workplace. I contributed the code for the double click feature when you click on mouse button 3, for example. And I also fixed a couple of problems with drag and drop under the Workplace shell. It used to crash here and there, and all these things are well fixed. In the recent past, I wrote this class replacement for the OS 2's hardware manager. I mean hardware manager. It's a thingy where you get the tree with all the devices list that you eventually also find when you run the rmview command. It's the same thing. It's the same info. It's a table of registered devices and drivers and how IBM calls us adapters and devices. basically it's a visual view of exactly this information. To be honest, I just did it for fun because, and for another purpose. There were a couple of people saying, I would like to start programming, but I have not in workplace shell class, and I wanted to go get into some, but I don't know where to start, and I have not the famous tool, and the documentation is also not that good. So I said, okay, let's tackle this as a project. It's a small project, it's not big, and publish the code together with the binary. So I put it on hops as a WPI file, and it also contains the code. I documented every line in this code so that people would get a chance to, if they really want to get into programming, into WP, so they might get a clue of, because there are also some of the more dark features of SOM and stuff that I covered and explained.
What's the file name?
HWman2 dot, I don't know, it's 2, HWman dot.
That's good enough.
For my own fun, I also wrote a post-it note workplace shell class. It was never published. I just tried to find out how does inheritance work with workplace with the SOM technology. So I experimented a little. I didn't completely finish it. But all this code, eventually Martin asked me if he could have it, and he put it on GitHub. So it's there, so that it doesn't get lost.
But it's called post what?
Sorry?
It doesn't mean about post it.
Yeah. I called it post what because I was afraid if they call it posted, they will sue me because I'm really, stealing their brand name or something. Okay. Very recently, there was a discussion on the VirtualBox help desk, no, not help desk, bug tracker. There was a problem with the Warp 4 kernel used under VirtualBox, in that if you had a program that would trigger the floating point exception, the whole kernel would crash. And the guys from VirtualBox had their fun fixing it, and eventually I came up with a solution in form of a PSD. It's a platform-specific driver, just like ACPI.PSD. It was more like a study of if it will work, because Stephen Levine basically said what the problem was in the Warp 4 kernel and why it crashed in this way, because obviously the floating point error should never take down a complete system. So it wasn't only a problem that VirtualBox had, because it shouldn't happen in the first place, but it was also a clear bug in the kernel. And I wrote this example PSD, or this test PSD, or whatever you want to call it, that fixed the problem. So, but this was basically just for fun. But it's still in the bug tracker, and if anyone is interested, I can put it on hops.
What does the kernel have? Exits you can poke into or something? How do you?
Well, in a way, this was even easier. Or the PSD is basically called at various stages in the boot process. Obviously, at the very beginning, and you have basically an init function that is called, and there I'd say I mucked around with the interrupt descriptor table, some low-level dirty stuff to fix the problem that existed in the kernel.
So that basically, with your PSD, made what was already in there replace it.
Well, the PSD allows you to basically, in the PSD you can do whatever you want. You can mess up the complete system. So I just used the opportunity to fix a problem in the kernel without modifying the kernel.
Right. So we could actually fix other problems like that.
In general, yes. Obviously, it always depends on the problem, but yeah, in general, you can fix errors like that.
I have not even really loaded the PSD for the Warp 4 kernel.
Yeah, maybe I have to say something. The original Warp 4 kernel didn't have the capability to load a PSD, but at the time when they merged together the development lines of the SMP kernel and the Warp 4 kernel, that guy called Scott Carfinkel, which was an IBM employee for a long time, who was doing all these updates to the kernel. he said, okay, come on, and it's all in there, so I can might as well just set it free, and so you can load a PSD in the later warp 4 kernel. So later means warp 4 kernel newer than fixed spec 13, warp fixed spec 13. So 13, 14, 15, you have this new kernel.
That was the big word. Yeah.
Yeah. Well, and last but not least, also unpublished. And only relevant maybe to developers. We already talked about VAC. VAC is this visual H compiler. It comes with a crappy, let's put it this way, development environment. It has a possibility to define projects where you could put in files, and it allows you to set up make files, settings and stuff, and generates make files, blah blah blah. But the thing I thought was interesting was it has something called the project access method. It's basically a DLL that you can throw in, and that allows you to replace the project's view of what is a file and what is a directory. Because normally you have directories and files in the real file system. There's basically a default project access method that does exactly that. Real directories, real files on your hard drive. And I just decided to experiment a little, and I thought, man, that might be a good idea to have zip files being and fake the project management to believe that a zip file is a directory, and the contained files inside the zip file are the files. So the whole idea why I did this was I have the DDK. You have a whole bunch of zip files, and sometimes you just want to look in there. You just want to click. Say, show me. I want to see. So I said, well, this is a good place to start a zip file viewer or whatever. So I can now define a project in the workplace that instead of having real directory files, you can add zip files to the project, and you can open the zip file. You get a tree of files. You can click on them, and you can run actions on them in workplace shell talk. And one of the actions obviously is to just click on it and view contents of the file. So, extract it to a temporary directory, and then it's just a graphical interface to zip and unzip. And for this, and this is also the reason why I did not publish it. I had to write a zip32 DLL. It's basically the complement of the unzip DLL. For OS2, no zip32 DLL exists, so I had to write one because I wanted to use one. So I got the code from the InfoZip community and updated the code to build an OS2 DLL, and then this is used by this.
It calls the native unzip. No?
Well, basically, the code is built up in a way that you can alternatively build either an executable or a DLL. And the DLL stuff works for unzip. And it also works for zip for Windows, for the Windows platform. But for OS2, they only have the executable, and I built the DLL. So that I think it's always more convenient to call a DLL from a program than an exe file.
Yeah.
That's the only reason I did that. Okay, but as I said, it's unpublished, and maybe it's a little bit nerdy, but it's just fun doing it.
That's all the BAC 308. That level of stuff you're talking about?
Yes, exactly. This version, the 30X VAC version, it has this graphical, the work frame. It's
right,
what they call work frames, development environment. Okay, now, as I said, I have been, did I say that? No. I have been developing C for I don't know how many years. Maybe close to 20 or so, and in real life, I do embedded software development on multiprocessor systems only. So in the year 2010, I decided, let's put it this way: in the year 2010, I had a computer. It was a single CPU, and it had a sys chipset, which I don't think maybe even exists anymore. I don't know. At least, I tried to use the IBM drivers because I just wanted to access the USB stick, and the USB drivers would really, they would just hang my system on boot. just would sit there and do nothing. And that was really frustrating because I just wanted to use it, but it was plain impossible on the system. And then I commented out the USB drivers and it worked. So I said, must be something about USB. So I decided, well, I could wait forever for something to happen, or I said, well, just what the heck, just try to get it fixed. And I don't know how it came about. I knew some people from the community, and I was busy in news groups and so on. But eventually, I got to this NetLabs.org place where somebody already had started putting the daily case sources onto NetLabs, and a couple of people had already started working on it. And for example, Rudiger Ile had fixed some problems with the hit drivers, in other words, mouse, keyboard, and this USB hit driver. So I said, okay, I'm going to start there instead of doing it, at home without ever making it public. So, okay, how did I start? Well, I didn't have any technical knowledge of USB really. I mean, I would know how to use it as a user, but I didn't really know how it worked from the inside. So I had to read a lot of documents. First of all, you had to read, there are 3 different flavors. Today there are even 4, but back at the time there were 3 different flavors of host controller. There was USB 1.x in 2 variants, like called UHCI and OHCI, and then there's this USB 2 variant called EHCI. So you have to read 3 documents, and I think the EHCI specification, I think it's at least 300 pages, and the other ones, UHCI is a little bit, it's considerably shorter, but some things are lacking, and the OHCI spec is also 300 pages or so. And on top of all that, you have to read the USB specification itself, because it explains in general of how USB works, what different data protocols exist, and modes of operation, because USB defines a couple of different modes of operation. You have a bulk transfer, that is basically transfer where you want to transfer rather large amounts of data, but you're not worried neither about latency nor about periodicity. So, for example, memory stick, you just want to shovel over data, but you're not really concerned about any timing. Then you have interrupt transfer, which is basically for all devices that need fast response. That's what they call interrupt. It's not really a hardware interrupt type of thing. It's called interrupt because you basically trigger off a transfer, and then at specific points of time, you get notified that the transfer happened. For example, mouse, keyboard, you want to have something now, if you press a key, you set up a transfer to wait for a key, and then somebody hits the key and you get notified. So then there's a transfer type called, I never can say this in English, isochronous? Asynchronous, exactly.
Asynchronous.
Asynchronous, not asynchronous. ISO. That is meant for devices that basically periodically stream some data, so you need some time behavior. For example, the webcam, where you want to, unless it works differently for other reasons, but if you want to have a steady data stream, you need this transfer. So when I started this, I naturally thought, well, I don't know why I thought this, but this was the way it started. I said, okay, it must be something at the very low level of the driver stack. And I have to explain a little about the USB drivers. The USB drivers are a driver stack. And there's a good reason for why it's called a driver stack, because you have a whole bunch of drivers. You know that? You have the 3 host controller drivers at the lowest level. Then you have a driver called USB-D.sys. It doesn't touch the hardware. It's just a managing driver. And the host controller drivers will register with this driver, so to make them known to USB-D. And then you have called client drivers, that basically, like client drivers are USB-MSD.add, USB-com.sys, USB-PRT.sys, and here comes the specialty, USB-hit.sys. They also register with the USB-D driver to say, hey, we want to send data or we want to receive data. And finally, to make things even more complicated for the human interface devices, means for mouse and keyboard. As I said, line driver is what's called even class driver in a sense, is the USB hit driver, because it is the managing driver for the other line drivers that register with USB hit. So these are USB mouse.sys and USB keyboard, since they register with the hit driver. So this is all a big, humongous pile of drivers. And what's even worse, maybe there's no other way, these drivers communicate a lot with each other, and since they all run in kernel space, they can freely exchange addresses. And instead of passing data by copy, they don't copy data back and forth information, they just send around pointers, Here's my memory structure, here's my, here's my infrastructure, take it, and use it. And I will explain in a second why this is relevant.
I mean, it sounds like a nicely layered design, actually.
Yeah,
it's not bad.
No, the design as such is okay, but there are some things to take into consideration.
I'm sorry, what can you repeat?
There are some things to take into consideration because of this design. So, what the current USB status is that a lot of internet research went into fixing problems in the three host controller drivers. And the problem is that yes, there is a standard, and yes, stuff should behave the way it's described in the standard, but unfortunately in reality, it's not always the case.
Yes.
And for example, to give you just one example, there's NVIDIA, which also has a chipset that supports USB 2.0, so they have a EHCI host controller driver, and at one point in time, I decided to move all the memory allocation to an arbitrary place so you could allocate anywhere in memory, which I think is a good idea on a 32-bit system. And then all of a sudden, the driver wouldn't work anymore for the NVIDIA chipset. And I had not the faintest clue what I did wrong, because it worked for everything else, until I hit the Windows out page, or the bug database of Windows, and they said this NVIDIA driver doesn't fulfill the EHCI specification. It can only allocate below 2 gigabytes. So the memory structure was allocated above that, and then it didn't work anymore. So I put in fixes for this specific chipset, and so this happened along the way. I think I fixed all known bugs that were around. There were a whole bunch of problems with the drivers. Rudiger Ide had already detected a couple of bugs in the driver when he was writing. He had this Emperor TV application. So when he offered support for these DVB-T sticks, he had to write drivers that would communicate with the host controller drivers, and that failed here and there and everywhere. And then I got in contact with him and said, what did you find? So I fixed it in the code, whatever. He did some binary patches to the existing drivers. I put this into the code. And there was a bug he couldn't even fix in the binary, in the OHCI driver, because it was bigger than, it just couldn't fill it in anymore. Because a binary patch doesn't allow you to expand the size of the executable. You can just patch at the place that you have. So he explained to me what was wrong, and I changed it in the code so that the bug would not appear anymore. And all along this way, when I was busy, or when I started doing this, Wim Rules called me, or wrote me an email, I don't know anymore. He said, I want to have webcam support under OS2, and it works fine with the UHCI, it works fine with USB 1.x, in other words, with UHCI or OHCI driver, but EHCI doesn't do anything. So I said, okay, I'll try and put it in. But then I got carried away with all the bug reports that I had. But what I did, the problem is, it's another one of OS2's problems. These drivers were originally 16-bit only. And the problem is that the host controller drivers, for their own management purpose, they need structures in memory for all the transfers that are set up and blah, blah, blah. So the problem was that worked okay for the byte transfer. There was no problem. For the interrupt transfer was no problem. But the transfers needed much more memory. They needed overall to manage every scenario. They needed 128K of memory. So that's far bigger than a normal 16-bit segment size of 64K. So I said, okay, let's change it, and I changed it all to a different addressing mode, to linear addressing. I had to rewrite all this part of the software, so that Wim eventually could have a fairly easy, well, easy is relative, but I mean, he could start off with something, you know, where he didn't have to even fiddle around with this nifty-gritty details. So at least I did that. So eventually now we have the support for the driver. And Wim has already written an application to a camera application where you can show webcam pictures and stuff. Okay, then there was another problem. I saw a bug report on the Ecom Station bug tracker a long time ago from 2006 by a guy called Jürgen Wülz. And there were also other reports that when these guys plugged in the webcam, the USB.sys driver would just blow. And nobody had an idea why and what was wrong. And there was one, I would call this a design flaw in the USB.sys driver, because the problem is that if you plug in a USB device, the drivers ask the device some information, like at what rate do you want data sent, blah blah blah, and what kind of device are you, and all this stuff. And there's the thing called configuration descriptor. You don't have to remember the name, but and the problem with this configuration descriptor is it contains such a whole bunch of stuff you need to know for the device to properly operate with. But this configuration descriptor can become very, very large. In terms, can become up to 64K of maximum size. And the problem is, the problem was that in the USB.sys driver they had basically static memory allocation. So they had a place and memory where they just envisaged that 1K would be enough for configuration size. And now there were webcams that were having 2 or 3K of config info, and boom, that was the problem. You were just overriding memory. So I changed all the static memory allocation to dynamic, so you can basically have arbitrary zone for big configuration spaces. Then I had a lot of problems with device attention. I thought they would be gone by the way I fixed the host controller drivers, but they weren't. I still had problems. And the biggest problem I had was basically, most of the time, you had a USB stick inserted on boot up, and either it would hang or it wouldn't work or what something. And using an external USB hub, it was even worse. It basically would never work with the external USB. So I looked at the code, and there was a whole bunch of delay loops in there that somebody had desperately put in to fix something, but obviously it didn't work. Obviously, so I went through a whole lot of trial and error, removing all this stuff, and only put the delays in at the places where they were required by the USB specification. There are some delays that you have to manage. If you plug in a device, you have to wait 100 milliseconds until you access it, because you wiggle it in and it goes, so you have to wait until this is over and stuff. So this obviously was put in or remained, but everything else I kicked out, and I basically rewrote this stuff. And I hope it works better than before, at least. And then the last point, Martin Kiewitz, I don't know if you know him, but he had published a lot of software. He was doing AirBoot, or he is. I don't know. Not for the OS2 version, but maybe for I don't know. But back a couple of years ago, he had provided some rec script to read data from his Casio watch, and it didn't work with the USB stack. So he had put in some fixes to the USB.sys driver and some zip file that he said but the problem was it was for an old USBD version. It was not the latest version that I had. And well, after a little bit of fiddling around, I said, I'm copying it. I'm going to pick up this idea, but I'm going to implement it myself. So, and then what it was all centering around was that Windows has a specific way of doing things when you plug in a device. And it doesn't follow the USB specification, but unfortunately, because it's Windows, I mean, every device manufacturer just follows, tests it on the Windows. If it's okay on the Windows, then everything is fine. So I just put it in because I said, just let's follow the Windows way. It makes no sense to try and fight Windows or something. Okay, after that, I had a look at usbcom.sys. There wasn't that much to do, but what needed to be done was today basically there's one vendor or one producer of USB to serial conversion chips called Prolific, and he's basically dominating the market, I would say. And the funny thing is, or the problem with usbcom.sys is, it still is, but you cannot change it. Normally, USB device classes like something like a COM device, they should announce themselves as COM class devices, and you shouldn't worry about the manufacturer or about the vendor or whatever, because if it's a COM device, it should be served by usbcom.sys. Unfortunately, for some reason I don't even know, this Prolific chip does not announce itself correctly. It doesn't say I'm a COM device. So the stupid thing is, what you have to come up with, you have to come up with a vendor and device ID list and say, this device uses the Prolific chip, this device uses the Prolific chip, this device, and every manufacturer can choose a different vendor ID. So you have you basically have a big table, and this table was updated. I was looking at the Linux sources. I completed the table. The table was rather short. It was the driver was 10 years old. So we updated this table. We also incorporated the Prolific specific code that was floating around in the internet in various versions and variants. And finally, there was some dynamic memory allocation in this driver that was again using this OS2 1.3 call to allocate memory, which basically means it's always allocating below the 16 megabyte physical address line, which makes absolutely no sense today. So I changed this to the new 32-bit allocation. Why would you care? You wouldn't care, but the problem is, again, if you have a lot of drivers who do it wrong and allocate below the 16 megabyte address line for the memory needs, if you load 20 drivers, you might get an out-of-memory boot up message with having plenty of memory. So this is the reason why I changed it. And I put in, to be honest, undocumented flag /L if you really want to allocate below the 16. For any, if something goes wrong. But I have never heard anybody complain, so I guess it's not necessary. But as a fallback.
On the USB COM.sys, you had mentioned for mass storage that you were interested in hardware. I don't know if you were to accept USB COM hardware to look at.
Yeah, if it's a problem, yeah. It's a time issue, obviously.
Oh, sure.
Maybe I should say that I'm basically doing this in my spare time. So,
sure.
Okay, for the USB PRT, that's the same thing as for USB-COM. There was some dynamic memory allocation that also changed. But other than that, thank God, nothing had to be done really about this driver. Now, for this was also a problem because there were a lot of people saying their mouse doesn't work, the keyboard doesn't work, or sometimes one works but not the other, and the next boot nothing would work. So there was obviously something wrong. And unfortunately, Rüdiger Ile, again, years ago, he had started updating these three drivers because there were things that were just not correct. So he did already take the first step, but unfortunately there was still a problem, and the problem was, as I said, the USB HID is basically a managing driver for the other two drivers. And now what the specific problem was if you have two separate devices, you have a USB keyboard with its own plug and a USB mouse with its own plug, the drivers were okay, nothing was a problem. But there are devices like these keyboard switches, the KVMs, right? And for example, I have an IR receiver that can handle mouse and keyboard, but now the problem is these devices are one device. They're just one device. Now the problem was that these composite devices, as we could call them, they have internally basically they're two devices internally, but not from the outside. So what happened was when you would plug in such a device, the USB HID driver would get a notification from USB-D driver that there's a new device. And then it would basically, in the loop, then he would find out that it's, for my device, it would be a mouse and a keyboard device. So he would notify one driver and the other, but there was no serialization. And the problem was, since it's only one physical device, there's a basically USB spec says, or spec, so not the USB specs, the spec, but the HID spec says you have to set up one device, and then you have to wait until this is all finished, and then you have to set up the next device and wait until this is all finished. So what I had to do is I had to build in some serialization into this driver to call the one driver first, wait until the driver finally says, okay, everything is set up fine, and then call the next driver, and don't do it all by at once. Okay, and now we're at the final topic. Because now I've started working on USB MSD.ADE, and the problem with this driver in particular is that the other drivers were fairly close to what IBM delivered as a binary, the latest binary 10.162 driver version. But unfortunately for this driver, this is not true. The source code that we have, and that was in the DDK, is lacking some features that some company called, I think it was Exigen from Latvia, had implemented on behalf of IBM in the very last year, days of very last days of where IBM actively supported those two. And currently, I think there are three topics with this driver that need to be looked at. The one that is maybe, the one that is relevant, where we have to find a prioritization, but what is currently open is the multi-LAN support, and I want to explain a little bit why this is and what it means. Multi-LAN support is necessary that, for example, if you have a card reader that has 5 slots, you have to distinguish between these 5 slots. If you plug in a memory card in one slot, and you plug in another one in another slot, at the same time, potentially, you basically obviously have to tell them apart. So if you want to address them, you need to be able to tell them apart. And this is what multi-LAN means. LAN means no logical unit number. So what it does is, what it is used for is to select one of basically the card slots. So if you have a card reader, you basically need multi-LAN support, because normally it has more than one slot for different card formats and stuff. So this works in the IBM driver, but it doesn't work with the current driver built from the DPK sources, because the tools just not exist.
You didn't go to Latvia and buy somebody a beer?
Well, I think the Ecomstate tried to contact guys from Latvia, but they're not. You cannot find them anymore. They're not existent now. They disappeared from planet Earth. I don't even know if the company. Yeah, Well, in short, you will not have a chance to ask anybody, and if you did, nobody would have the source code, I guess.
Right.
Okay, the one other thing that I have personal problems with, and I thought maybe that should be fixed or looked at, is, and which I started now, but we can discuss if this is the right prioritization. Another problem that I have is that I think we need an automatic drive eject on shutdown. The problem is, at home, I have a box and I have a, what do you call this, a Western Digital book. Basically it's a hard disk with a USB connector. And obviously I have this thing, I want this thing permanently attached. I want to plug it in and leave it like that. Boot up is okay now. It will find the hard disk and it will be operable and everything, in contrast to years ago. But the problem is, when you shut down the system, there is absolutely no code in this driver to take care of the fact that you have to flush the file system and that you have to basically unhook everything, all of the partitions that are served by USB and STD. In other words, all of the partitions that are in your memory stick. So what I started doing now, or what I did already, is find a way to find out what partitions do you have, what disk drives exist in your system, and which of these are partition hard drives. In other words, which of these are USB partitions or drives. And as so often with OS2, you don't have any documentation. I mean, and you cannot ask anybody. So I had a look at the OS2 DASD and device manager driver, the one that basically is the interface between the file system and the real driver doing the real data transfer, which in this case for USB drive is this drive. And thank God I found an interface to query which drives exist and which partitions exist in the drive. So now I know what drives exist, what partitions drive, what partition, what drive letters do they have, blah blah. And I also found a way into calling into the OS2 DASG driver and setting off a command to eject the hard drive. Because you have this eject exit utility that allows you on a command line or even from the user interface to eject the drive. And basically what I want to do is mimic calling this eject exit. Unfortunately, it's not that easy. I have set this up, but it hangs the system on shutdown, so I have to do some more research, or potentially I have to come up with another solution, like having a daemon program that basically calls into the driver, hangs in there, and when it's time for shutdown, then issues the basically eject functionality. I have to just need some more research and try to find a solution that works. Okay, now from what I've heard or from what I read from various from OS2 World, for example, from the forum, it seems to me that maybe the biggest problem right now is the handling of large floppy devices. Basically, if I read correctly, but correct me if I'm wrong, if you format a USB stick under Windows, there's no partition on the stick. It's handled like a big, large floppy. You don't have a partition. It's just treated like a floppy. You do have an MDR, I think, on each device, I think.
No, if it's a large floppy, there's no MDR. There's just a partition boot record and then the rest of the files.
Okay.
But I don't think the standard format on Windows will do that. A lot of the memory sticks that you get off the shelf, so from the shelf, are formatted in such a way that they're just delivered as large floppies.
Windows will create as a large floppy, but
always?
Not always.
Oh.
No, at least I don't think always, but it can do so.
Yeah, well, it doesn't really matter. I mean, they exist. We don't do anything with them at the moment. And the problem is that if other people have sticks with data on them or pictures or whatever, we can't really do anything with them on the station.
If you partition a disk manager, it will be a hard drive, but if you don't,
Yeah, by default, I think it will do it as a large floppy.
Okay.
And unfortunately, okay, let's put it this way. This driver offers you two different possibilities. It does, astonishingly. You can say that everything you plug in is a large floppy. You have a parameter to this driver that it's called removable as floppy, and basically that would be what you want to have. Unfortunately, this is a global parameter, so whatever you plug in, it's treated as a large floppy. And
Did you get it to work though?
and that might be another problem. But I mean, there's a foreseen way at the end. But unfortunately, IBM's way, or OS2's way of dealing with removable media is to partition it. And the reason for this is that the relevant file system that OS2 offers, so that's HPFS and JFS, they all require a partition. You cannot format a large floppy in JFS or HPFS. It just doesn't work. At best, you can format it with FAT32. I'm not sure about this, but
I don't think our FAT32 will handle, our FAT32 I don't think will handle floppy.
no, it's only a file system. It doesn't know. The file system doesn't know about partitions and such. But I think this is exactly where we can end the conversation.
In fact, discussion IFS will mount such a thing. You cannot format FAT32 when I was doing anyway. You could format FAT32 large floppy using DUC. DUC doesn't care whether it's a partition or not.
Yeah, but once it's...
Yeah, you have to mount it some way. So
Yeah.
the FAT32 IFS combined with those two, the SD and your MSD driver will have to supply the information to FAT32 IFS that it will allow to mount it somehow.
But then that's all LEM based too.
Well, LDN is tied in there as well. But
And that's where I think part of our development problem would be, is to integrate it into LVM. What if we used a different approach and used the net drive interface?
Sorry?
now you work in some way, but really slow. So we'll go back.
Net drive?
Yeah, net drive. We currently use it as our ecom station virtual file system.
Okay.
And there's been different add-ons to support, different file systems, remote file systems under FTP, and then local file systems. There's an implementation of was it FAT32 or no NTFS? And so if it's extensible enough to do something like that, maybe that might be an interesting interface to look at implementing MSD on our sticks.
Well, in theory, yes, but you don't want to re-implement the whole FAT32 IFS logic, or somehow you want to reuse them. I mean, it's just a way to direct it to a certain bunch of sectors on that thing. So it's really simple.
And
It doesn't need to be hard. You don't have to rewrite some IFS or something. So
and
it's technically possible, but it's not the best way to do it.
well, I was thinking where we're talking about ejecting the media, shutting down that remote file system, if you will. I believe there's constructs already built into that client technology, virtualization file system technology to do an orderly shutdown with the ecom station shutdown process and do the ejects. But
I don't think so, because I think when you have, for example, if you have a hard drive managed by this ADD driver like AHCI driver, I think it takes care of flushing everything to the disk when the system shuts down. It's the job of this low-level driver. So you would, to achieve the same for USB disks, I think this ADD driver would be is the place to put it.
No, it has to be there.
Yeah.
Because from a logical standpoint, there's no difference between the AHCI controller and a USB controller. You're doing the same functions with the disk.
Well, yeah.
Yeah, you got a different interface, different command set, but it's the same functions.
I mean, the current solution I'm using myself right now, because it's the only solution, is I'm using Xworkplace with a shutdown folder and calling eject on all my drives on shutdown. So that's well before the shutdown is initiated on a driver level before you get the shutdown command. You're basically done with everything.
Basically,
This is okay, but I just try to find a solution that is basically transparent to the user. I don't want to have people coming up with some.
And we might not be running PM shell, we might be using a headless scenario. And if you're shutting down, you want all the devices to do a shutdown.
All that, even exactly. If you don't have a graphical interface, then you cannot do that.
the thing is, the drivers know the shutdown is happening, and they can do the right thing. Now, eject is a little different, though.
Yes, it's more involved because.
Well, the problem is, which happens first, the eject or someone telling you. The problem is an eject is basically you're telling someone what you're going to do.
Well, I try to investigate if this is basically a synchronous action. In other words, some action that you trigger and it will finish before it returns.
Exactly.
That was difficult to track because it goes into the OS2 DASD driver, and well, I went through the code trying to find out what happens if I trigger the eject command from this utility. What actually happens? Which code path in the DMV driver does it take? And it was not all that obvious. Let's put it this way. So
What about I think I have a USB floppy and that works okay on OS2.
yeah.
Does that have any clues about
Yeah, that's an it works.
that? But that's a separate world from this stuff.
Totally, yeah, because it's basically right through. There's no real cache.
There's
exactly.
no caching to worry about or
It's
anything.
effectively, all of this becomes a problem when you're using a file system that sets up a file cache.
Right.
So if you have JFS or if you have HPFS and you have set up a cache, then you have a problem. If you set the cache to 0, obviously there's no problem because there will never be anything in memory that needs to be written to disk. It will always happen immediately if you have. But this is exactly the problem. We have just a file cache, and it has to be flushed to disk. And what the eject utility does is it just calls a function, an I/O control function, that basically will trigger exactly that. It will basically tell the OS2 DASD manager, come on, call all the drivers to get rid of this stuff, to write it to the media. And that was the reason why I tried to mimic this behavior in the driver, that I tried to call the very same thing that eject.exe would do.
Related to what you're talking about, I find that if any of these things get into trouble, like for example, I have an NTFS drive mounted in that drive, and I try to dismount and it fails. Or if I have ISOFS and that won't dismount, or I can't eject the USB, then when I try to shut down the system, it hangs in the file system shutdown phase, and I have to use the big red switch, in my case the little gray switch, and then when I reboot, it's got to check disk everything.
You have this effect.
Right, what?
You already have this problem.
Yeah, right.
Yeah.
And like I say, if any of those things is in trouble, it seems to short circuit and prevent the entire file system shutdown. It goes into file system shutdown and then hangs. Okay. And it's hung. I have to use the switch and then reboot.
Yeah, I think this is one of the problems.
Is there a way to bypass what you're having trouble with and at least shut everything else down so you don't have to check disk everything when you reboot?
But I can only say the current implementation inside the USB MSD driver, when you have a shutdown and sets a flag, do not accept any other data transfer command anymore. That's all. So that's the problem. You have stuff in the cache, and this driver just says, don't ask me for anything anymore. I'm not going to do anything anymore. But as I said, you have to get the stuff flushed to the media, and this is lacking in the driver.
What is the mechanism for using cache on file cache on the USB MSD? It doesn't use it.
It's not at the USB level.
Right.
It's a processing level. The processor will have cache, most likely.
Maybe the layering is you have a file system. The file system calls the device manager. So that's basically file system calls into OS2 DASD.dmd, for example. And OS2 DASD finds out on what media is this thing really physically, and then it's
USB, whatever.
and then it picks the correct low-level driver, which will eventually do the real work and basically write stuff from disk or read stuff over.
Would that be write cache then too? Or just read?
No.
Okay.
Read write cache. The cache implementation is not part. It's not part of the manager. It's not part of the low-level driver.
Right.
The cache management is only done by the file system. The file system. is the
And
only
so MSD is not really the file system. It is the file system.
No, it's the low-level access to the hardware media, to the media. Sorry.
FAT32 IFS or JFS IFS, that's the file system. That has to be.
So what's missing? You get notification of the shutdown in the driver? Is that there or not?
I get notification of the shutdown. I already implemented the stuff to eject, to call this eject command manually.
Right, but what you really want is when you're notified to hook back up in the stack to talk to the file system to ask it to please flush itself?
No.
Or?
Because I'm generating the eject command basically.
Mm-hmm.
So that does everything. In principle, the eject executable does everything that needs to be done.
Mm-hmm.
If you call the eject program, basically it will trigger some I/O control call, which under the hoods will call into the real driver multiple times to just get rid of all the data that is still cached. It will be data transmission requests to the media to write down and to write the data to the media.
From the files, at the file system level or at the driver level?
On the file system level.
Yeah, well, actually just
This is all kernel internal. You know, I don't. For me, it doesn't matter. I know that there's some mechanisms that I can call that will allow every cache to cache to be written to the disk. And I'm trying to call this from this driver to exactly.
But you don't know what it is.
And
You don't know what to call.
something that'll work.
Yes, I do, but the call doesn't work for some reason that I don't know.
Oh, I see.
There's no I/O.
Because
Like when you shut down a fixed hard disk, what happens? Is the driver notified and then the driver notifies the DASD manager to ask the file system to flush itself?
No, the driver will get a shutdown command, and it will get everything that is still.
Because it's all the same parts. They're going to get flushed anyways because shutdown calls the file systems and tells them to flush the caches. And it's all the same cache. And it won't eject it. That's a whole separate issue. But the JFS cache is a single entity. And so when it's told to flush, it's going to flush no matter what the media is, unless this shuts down first, which should.
The only thing I can say is that every time I boot up, I get a chance to check this every time.
Well, what you need is some heuristic where you figure out when the I/O is actually stopped, so you can.
It's a timing
shut
thing.
down until you know you don't need any more I/O.
Well, maybe I have to discuss this exactly.
Maybe you just need to set that bit on the thing.
What's checked?
The large floppy.
It's not dirty.
Hopefully it doesn't work, because usually it isn't dirty. But when it is dirty, you're screwed.
But this is basically something I'm looking into it, so because it's really annoying, you know, you shut down the system and every time you reboot, I have to always try to check this command on my JFS drive. It's fairly big, so.
Unless you remember to eject it manually.
Yeah.
Yes.
That's the.
So well before the driver gets into the shutdown phase, basically.
Yeah.
Because if you do it from the desktop, obviously,
Yes.
well before you turn
It's
off.
probably mainly a timing issue that the file system driver is getting shut down and it's trying to flush.
Yeah.
But in the meantime, your driver also gets to shut down as it stops responding to anything. So then the file system driver cannot finish its flushing.
Yes, easy.
Something
So
like
the first test would be to put in a delay. Okay.
Basically, you're shutting down too fast because IBM never considered running JFS off USB sticks. So it's your job to delay your shutdown until you're sure you're not going to need more I/O requests.
Okay.
You know, coming back and trying to do eject, you're just going to make more I/O and make the thing recursive and never work right.
Okay.
And also, there's a good possibility if you issue the eject at that point in time, it's too late in the shutdowns anyhow for it to issue any more I.O. Because there's a certain point in time where it'll finish I.O., but it won't issue any new I.O.s. It'll just fail.
Well, I already saw that calling the eject.exe will lead to data traffic. You will get a series of data transmission commands into the driver. So yes,
Yeah.
there's something going on. Yeah.
And that data traffic may even cache. Yes, basically you've got to sort of add a delay in there, knowing that, and it may have to be a switch, or you just basically got to know basically how fast it takes for you to do I/O, or to see I/O traffic during when it's doing the flush.
Well,
It can probably be pretty quick. You know, if you wait a couple hundred microseconds,
I can
100 milliseconds, and you don't see any I/O,
I could also
it's probably flushed.
I could also set up a timer and everything. The time I get a new command, I can rearm the timer, and when the timer expires, then I know.
Exactly.
But if the driver gets shut down, do you have to acknowledge it in some way?
No.
No.
It's a one-way
just
street.
a notification.
Yeah.
It's a one-way street. You cannot say wait a little, wait.
Yeah, right.
Please don't. You can just block. I mean,
Yeah, but
That seems like a good idea that, stepwise waiting.
yeah.
Yeah, it's basically to wait until you return and say, oh good, you're shut down.
So you don't
have
get
to
any,
block that I/O until all
you
the
don't
other-
get any report back from the IFS when the flush is complete?
No.
Not
That's a misdesign. Or it was not foreseen. For removable media to have something that is cached. I guess they were just envisaging that you use FAT.
Right.
But even FAT can have some cache.
Yeah.
FAT16
This
even can be
driver's
cached.
actually-
So. Yeah.
Faster than one point, faster than HDFS.
Yes.
Now, what are the large floppies? Do they write through just like small floppies? How does that work?
No, I don't think it has anything to do with write-through. To be honest, this is a new topic for me, or at least I didn't bother up to now, even though I know that, yes, there is a problem. I think it needs to be investigated of how we can, I have to put it another way. This driver, the USB MSD driver, defines basically, I think, 4 or 5 mass memory classes, to put it this way. It's a floppy class, it's removable disk, fixed disk, and optical disk or something. And forgot CD-ROM. So fixed disk is never used for some reason, it's just not used, this class. So I guess what we have to do is to support large floppy is to for everything that we want to be treated as large floppy, we have to basically change this driver potentially in here to report back to the manager driver that it's a floppy device, for example. But because it will hopefully handle different, but I haven't dug into this.
Yeah, I sort of know how to do it, but I haven't worked out the details. Essentially, what you have to do is manufacture a phantom MBR, and then move all your physical sector numbers or logical sector numbers that you report back off by 1, so you replace with this MBR, and you maintain the MBR in memory, and then you simply, when you do your physical write, you adjust to write to the correct place on the disk, because there is no partition table. So you're off by 1.
Yeah, but I mean, you always the device manager can handle unpartitioned media, floppies, for example. He can
Yeah, but
floppy.
the problem is it only handles them up to a certain size, so once they're bigger than that, if you want to handle it, you've got to thick a partition.
Well,
Or fix the device manager, which is a big job.
well, hopefully, I think they invented, or they tried to allow, at least at one point in time, there was a flag that you could specify for the device manager that you were using large floppies. But in the old DASD code, they have it in there. I didn't even know if it's supported anymore. I don't know.
Yeah, it's probably not anymore.
But I think the idea was to support partitionless media that is bigger than the real.
Right, but the
real
problem
size.
is, as a sanity check, they only allow the partitionless media to be of a certain size.
Like
Or
LS
error
120s
checking
were
anything
about
else.
as big as they got.
Because if you think about it, there's no reason they can't handle 64 gigabyte large floppy, except for the fact they choose not to. Not the field sizes or anything like that. It's just, it's too big, so they say, well, wait a minute, maybe the thing is not really a large floppy because it's too big.
Just go in and partition it. Move a few things around.
But Steve, couldn't you just patch the check out? If it's only just checking
If
and
that's
it's...
all it is, yes. Someone's got to go find out where the check is and turn it off and start doing some testing and see who breaks. You know, my guess is that's all it is. It's a sanity check, because I can't imagine that the field values are not at least 16 bits.
You mean for larger media than
Internally, when it keeps track of this stuff.
For large
Keeping
floppy.
track of those sizes, it's got a BPD for this stuff and all that sort of stuff. It's not like it's keeping CHS values. Because then it wouldn't even handle 32 meg. It wouldn't even handle 2 gig.
Okay, as I said, I just started with this driver, so
Yeah.
it's a whole, it's
before
another
I-
layer of complexity with this device manager thing. That's
Yeah. Before I started going down this path, if it was me, I would actually figure out why it will not accept greater than 2 gig. And then we'll go from that to a solution. If I wanted to handle the partition list larger than 2 gig.
Yeah, actually, you might first want to try out if it's really a size thing or the file system. Maybe it's the file system.
I think we sort of already know that, because if you stick a 64 gig large floppy format, it simply won't be mounted.
Well, if you got a small stick, like a 1 gig stick and format of FAT32, large floppy, which you can do, I don't think it will accept it. It will accept it if it's FAT16. So there's also a link to the file system. The FAT16 driver is internal to the kernel, more or less. And the FAT32 is an IFS. So there's probably some additional, some additional logic needed to mount this thing and present it to the FAT32
It may not
IFS.
just be size related, Just make, you're
It's
right.
not just size, it's also contents.
And it's not impossible that they actually go off and check to see if it's
foot is on the
again,
left
another
and it's
sanity
lifting
check.
this leg off the ground.
Again, all patchable if you understand why it's not defining, why it's not accepting it. Right now, all we really know is that it doesn't accept it.
Yeah, I'll just have to dig into how it really works.
exactly.
Well, yes, at the moment.
The good news is that code is relatively straightforward and easy to try, walk into and come to
Maybe we should get in touch, because I'm really the expert about file systems, so that helps.
Well, I'm an expert on how the file systems are on the disk. Steve's more an expert on how to handle
How they get to the disk.
Well, I learn as I go.
But I'm willing to learn. And I have some experience with USB as well. I've been doing embedded software development too, also with USB. So I'm a little bit aware of some of the issues.
So the question is, how do we go about this topic, right? This is even more pressing. At least that's what I understood from the current discussion.
You got small font there, you're gonna have to make that.
The large
I can't
floppy
read
is,
that
sorry.
out of distance.
Yes, unfortunately.
Yeah, I think we
That
may
should have been two
overrun on
slides.
the,
Next time you do this,
question.
that's 2 slides.
Yeah.
Three.
Us old folks, we've got updated without
Less and
magnifier
less often
lines.
as people stop using sticks.
Well, but USB is USB is one of the few ways to exchange data. And over the network.
Over the network, right. Over the network is completely wiping out
You need
all
something
the,
port, carry around. Then
Yeah, fortunately, Bluetooth is not so pervasive that we really need it. But USB, we really need it. And eventually, we're going to really need USB 3.
Yeah,
But that's really,
that's my,
that's really just a more a matter of someone sitting down and putting the labor in to write the code. It's not really an unknown entity, it's just a certain amount of code.
There is what the question that we have on the community is what I already asked you tonight, but this is the presentation. What is the effort to have USB 3.0? What is the effort needed? Or how big is the work to have to create USB 3.0 working?
Well, it depends on how you go about it. Maybe, to be honest, I don't think I will have the time. For me, it will be too much, I guess. But I think that the feasible way or the best way to go about this is to port an existing driver and a 32-bit version and basically put a glue logic around to fit it into OS2. In other words, do the 16 to 32-bit transition thunk stuff. But it's going to be less work than starting from zero.
Well, not really starting from zero because we have a good working 32-bit shell that we use for multi-Mac. And it should be adaptable to be porting other, it's got all the standard hooks and all that sort of stuff. Load 16-bit turns itself into 32, ends up being flat address space. The real question is how close is the driver model of the 32-bit driver to what we need to be an ad driver, and so on and so forth.
So there's something in
Well,
there.
actually, not really ad, not for this, but.
What's involved, just the low-level drivers need, you need a new one, like the EHCI or
Yes,
at that
that's
level?
all.
you need a host controller driver. For
Otherwise, above that, it hopefully would remain steady.
Yeah, it should be.
Yeah.
My gut feeling is we have to do some changes to USB because
That's layer 2.
some of the internal information structures have changed with USB 3. But the main part will be to write the new driver on the host controller driver.
Right.
Yeah, and that's not really a big problem because we have control of all of those sources. You make the change, you rebuild everybody to be compatible, yet you can't work. You may not be able to run the old UHCI driver with the new USB 3 driver, but that's life. You just have to upgrade it as a set.
You mean the USB-D?
Well, yeah, you update that, and then you have to upgrade all four of them. You have to upgrade, whenever you update USB-D, you may have to upgrade all of the controller. We don't know yet.
First shot, I would hope that we don't have. We can do an alternate path in USB-D and say, if USB 3, then do this, otherwise do that.
Yeah. Depends. It really
When I look at
does.
the Linux code, it looked like it. Basically, they had to also jam it in somehow. So.
But see, it may just be bigger to add structured fields and not use them for the other controllers. Because then things are the same size and there's less conditional logic.
Yeah.
And it just simply doesn't matter because you're not going to look at it.
Yeah, okay, as I said,
It's
we have.
too early to talk about that, but there's a lot of ways to do it.
Yeah. Okay,
Well, thank you.
yeah, basically.
Yeah.